Okay, so today we're going to talk about a 13a, exercise 13a, differential equations. It's the first exercise of chapter 13, differential equations. It's just a first introduction exercise, so it's actually pretty easy. So first thing we need to understand what is meant by differential equations. If you look at the word differential equations, first of all, that is an equation. So it's like, a normal sort of like an equation we have before, like a linear equation, quadratic equation, cubic equation, trigonometry equation, but this time it's in terms of differential equation. So differential equation, DE for short, is just an equation involving derivatives. That's why it's called differential equations. All right, so I just want to show you a couple of differential equation examples. Okay, so you've seen those type of question before. We just never really used the name of differential equation, sort of to understand, to talk about this is the differential equation. Okay, now differential equation obviously is an equation in terms of derivatives. Something that's really, really simple would be y dash equals to 2x. All right, just like that, y dash equal to 2x. The derivative of function is equal to 2x. That is a differential equation. All right, it is. All right, you've got an equal sign here. You've got a derivative, the first derivative here, you've got a function, so that is a differential equation. Second one is, you might probably never seen this before, but you can have y dash is equal to 8y. That's also a differential equation. It is an equation involving derivatives. You can also have differential equations with different powers, like 3y plus y squared. That's fine as well. We can also have a higher order differential equations like y double dash, okay, plus y dash minus y is equal to 0. So I just randomly make an equation. That's also a differential equation. You can have something that's a bit crazy, like combination of x and a y double dash, x squared y double dash plus 2xy dash minus y equals to 0. That's also in a differential equation as well. Okay, all right. Now the next important things you need to understand is the order of differential equations. Okay, so when I'm dealing with the order of differential equation, all right, the meaning is order just means the highest derivative that occurs, all right, within it. So within the equations here, so we can have like an order 1, which means you will have the first derivative in the equation, or a second order differential equation, which is like the highest derivative is second derivatives in the equation. So that's what is called the order of differential equation. All right, so it's the order of the highest highest derivatives. All right, in the equations here, that is the order of differential equations. Okay, all right. So in this chapter, all right, majority of the time we're dealing with the first order differential equations. Sometimes we do have a few examples of the higher order differential equations. Okay, so what is sort of like the question that you're going to do with differential equations? So the first type of question that you're going to see is to actually solve differential equations. Okay, it's solving differential equations, but if you think about it this way, all right, whenever we start to find the, whenever we introduce an equation, different type of equation, the first thing we kind of things to do is like, you need to know how to solve it, right? So we basically need to know how to solve a differential equation. Okay, so I'd like to show you a few examples, all right? But things you need to understand here is sometimes the differential equation, the solutions are not just numbers, but it's a function of x. Or sometimes it's more general relationship between x and y. So it's not like when you're solving the equation 2x plus 4 equal to 0, x is equal to minus 2. It's not like this kind of question anymore. The answer is like, in most of the time the answer is in terms of numbers, but this time with differential equation, the answer is in terms of a function of x, or a relationship between x and y, or a function of y, okay? And we can always test whether the function is a solution of differential equation by substituting that into the actual equations there. Okay, all right, so For example 2, I would like to do the questions where we need to test, okay, to see whether, the following function is going to be in a solution of differential equations. So I'm just going to use the examples from the textbook. So if you look at the examples from the textbook, example 2, okay, so let's have a look at example 2. Example 2 says, test whether each function is a solution of the differential equation y dash is equal to negative 7y. So the way to do a question like this one here is, we do the substitution to see if that becomes, the solution of differential equations or not. So for example, that is the solutions we have. So that's the differential equation. And we need to test this function here, y equals to 20e to the power of 7x. Okay, we need to test if whether this is, whether this function here is a solution to that differential equations or not. Okay, so it's actually pretty easy to understand here, and it's pretty easy to do this question. So we just need to substitute. Okay, so sub y equals to 20e to the power of 7x into the differential equations, and hopefully we can prove the left hand side is equal to the right hand side. So the left hand side is y dash, which means we need to differentiate this function here. So that becomes 20 times by 7 e to the power of 7x, 140 e to the power of 7x. The right hand side is equal to minus 7y. Okay, so we just need to substitute the value inside. Okay, minus 7 times by y, and we know what y equals to. Y is equal to 20 e to the power of 7x. That's minus 140 e to the power of 7x. So as you can see here, the left hand side is not equal to the right hand side. So therefore, that is not a solution. Okay, so not a solution. All right, this is the type of question we're doing here. We just need to prove whether this is a solution or not by substituting. Okay, so I'm pretty sure the next one would be the solutions of of that differential equations here, when the power is equals to negative 7x. Okay, but it's good questions where to show you this is how you actually prove whether this a function is a solution of differential equations or not. Okay. All right, so let's move on to the next example here. Alright, so the next example asks you to show that y equals to tangent x is a solution of a differential equation. Don't be surprised. We can also have, a function that's like a trig function is a solution as well. So it's, it's multiple. You can have a logarithm function, inverse trig function is a solution as well. Okay, so we're going to show y equals to tangent x is a solution. Okay, of y dash equals 1 plus y squared. Okay, all right. So you need to use, All right, so remember you need to use your differentiation methods. You need to be able to, how to differentiate trig function, inverse trig function, in order for you to actually do the questions here. So we'll start from the left-hand side, which is y dash. All right, and we need to differentiate this function here, okay? The derivative of tangent x is equal to sec square x. Hope that's correct, okay? And the right-hand side is equals to 1 plus y squared, which is 1 plus tangent square x, all right? And then in this case here, that is equal to sec square x. So the left-hand side is equal to right-hand side. Okay, so that's how you show this y equal to tangent x is a function or is a solution to that differential equation. So you might be asking again, the question we're dealing with here, like in example 2, is we just show whether a function is a differential is a solution of a differential equation, but we didn't really solve, right? I remember at the beginning I was saying how do we solve a differential equation? At the moment, for this first exercise, you don't need to know how to you don't need to know how to solve a very hard differential equations. In future exercises, you need to know how to solve a particular differential equation. There are pretty hard differential equations that require a much harder way to solve it, which you don't need to know, and it's not in this course. You're probably going to study that at university level. Okay, all right. So let's move on to the general solution of the differential equations. Okay, all right, so when it comes to the general solution of any differential equations, just means normally we will have some constants, all right? So it's like we can have a family of curves where that gives you the same answer. So I want you to think about, the normal differentiation. If we have a constant number attached at the end, like for example, 2x squared plus 4, 2x squared plus 8, 2x squared minus 7, if you differentiate it, it's always equal to 4x. Okay, so therefore, if we have y dash equal to 4x, then the solution for that differential equation is y equals to 2x plus c. Okay, this is the type of answer we have, right? We have a family of solutions. It's not just one single solutions. The reason, for example, like we have a constant number at the end, because it doesn't matter what is the constant. If you differentiate it, it's always equal to 0. So that's the reason why we can have a general solution for differential equations where there's a constant attached. And you can find out what is the constant by knowing a certain condition. So they might tell you when x equal to a certain value, what's the y value, so you can solve for c or solve for any other constant. So that's the type of question you might also get later when we're dealing with some differential equations. Okay, so what I would do is I'm probably just going to pick a question from the exercise. So instead of using the sample question, picking a question from the exercise and show this is a general solution. Okay, so let's have a look at question 10. It says, verify by substituting that the given function is a general solution of a differential equation for all values of constant a, b, and c. I'll probably just do question 10D. All right, question 10D, which is here. All right, so if you have your textbook, make sure you also look at the question 10D. Okay, so we've got y double dash plus 2y dash plus 2y equals to 0. And we need to show that, show y equals to a e to the power of minus x cosine x is a solution. Now remember, this is a general solution, as you can see from here. It's in terms of the a, so that's why that must be a general solution. All right, so to show that, we again do the same thing. Left hand side is equal to y double dash plus 2y dash plus 2y. Now, with this one here, what you can do is you can break down it into several parts. You can start with y dash, okay? I'll actually start with y. So y is equal to a e to the power of minus x cos x. Then y dash, you can now start to do the differentiation. You don't have to do the derivative here, so do an aside here, and then you do a final substitution at the end. Okay, all right, so y dash, we need to differentiate that using the product rule. So that becomes minus a e to the power of minus x cos x minus sin x a e to the power of minus x. Okay, all right, that is the y dash. All right, so let me just probably, let's just rearrange it. So therefore, y dash is equal to, take the minus out. If we take the minus out, and we take the a out, or e to the power of minus x out as well, so we factorize it, we get a cosine x plus sine x. Okay, that's pretty good. All right, so this is the first thing I need, that's y dash. Now I need to find a second derivative. Okay, so by using the product rule again, so that becomes a e to the power of minus x, copy everything down, plus I need to differentiate the second part of the function, which is minus sine x plus cos x, and copy everything down here again. Okay, just have to be very careful. All right, once I finish that, I can now take out a common factor, that is cos x plus sine x. Okay, and that becomes plus sine x, and then if you take the common factor, that is minus cos x. Okay, so I hope that's correct with my algebra here. All right, so once this is done, then you can cancel the terms inside. So we end up with 2a e to the power of minus x sine x. Okay, all right, so this is the second one, all right, y double dash. Let's hope after we substitute everything inside, we do get the answer equals to 0 on the right hand side. Okay, so let's substitute. Y double dash is 2ae to the power of x sine x plus 2 times by y dash, which is minus AE minus X cos X plus sine X. Okay, oops, I don't have any space for that. Okay, I need to plus 2y. Now plus 2 times by y, which is 2AE minus X cos X. Alright, so if we expand everything, let's see what we are going to get. Sin X plus 2AE negative X cos X. Alright, so after expanding, it looks like we can cancel this term with the terms here, and then the term there with this term here. Okay, so great, perfect. That is equal to 0, which is equal to right hand side. Right, so that's as you can see, that's how the way this question need to be done. You just need to follow the question. According to the question, you need to show this is equal to 0. So you need to find out what's what y double dash, what's y dash, and what's the original function. Substitute the value inside and to get to the value. Okay, so that's how you show that is also a solution of a differential equation. So the majority of the time in this exercise is all about show it's a solution of a differential equation. It's not really easy to solve it, it's just show. All right, now I would like to do a question when they instead of ask you to actually find the a general solution, we probably need to find a particular solution when the question gives you a particular value. So let's find a question. So hopefully that gives you a question where you need to find the answer. Okay. All right, so if we look at question 15, okay, question 15, use integration and initial conditions to find the solution of y double dash equals to sector square x, with y 0 equals to 1 and y dash 0 equals to 1 again. Okay, now they give you two conditions here. The reason for that is because you start the equations with second order differential equation, and that's why you can have two. If it's a second order differential equation, then you can have two constant. If it's a third order differential equation, you can have three constant. All right, so you need to have three conditions to help you to solve it. All right, so y double dash is equal to sector square x. That is a differential equation. We know y0 is equal to 1, and then we also know that y dash 0 is also equals to 1. All right, we need to find a solution to that differential equation here. So that's actually pretty easy to deal with. All right, we've done this integration several times. So we know y dash is equal to integrate sec square x dx, and that gives you tangent x plus c. Okay, so that's the first. So from the second order, now I have changed that into the first order differential equation. I just need to find out what is the c value. Make sure you find the c value after you finish each integration. Don't leave that into c1, c2. Otherwise, it's going to be hard to find it later. All right, so if we sub x equal to 0, y dash equals to 1 into that, so we get 1 is equal to tangent 0 plus c, and c is equal to 1. Okay, all right, so once we have c equals to 1, then y dash is equal to tangent x plus 1. Now from here, we can find out what is the y value. So y is equal to integrate tangent x plus 1 dx. I'm going to do it here. So y is equal to negative ln absolute value of cosine x. If you don't remember y, sine x over cos x is is how you actually simplify the tangent x, and then you can use the logarithm to integrate it. All right, anyway, let's continue. Plus x plus c2. All right, so now we need to substitute x equals to 0, y equals to 1 into it. Okay, so that gives negative ln cos 0 plus c2. So finally, what's this answer here? All right, cosine 0 is equal to 1, ln 1 is equal to 0, so that's equal to 0. So therefore, c2 is equal to 1. Okay. All right, so the final answer, fortunately, I'm just going to write here, okay? All right, so if we know c2 is equal to 1, so the final answer, y is equal to minus ln absolute value cos x plus 1. and that becomes the final answer to that differential equations. So as you can see, this is a particular solution. It's not a general solution anymore, because we have a condition that tells us when x equal to a certain value, what's y and what's y dash. Okay, so that's about it. All right, it's all about just understanding what is a differential equation and how do we find a general. Well, not how do we find a general solution. How do we show it is a solution to that differential equation at the moment, okay? And then how do we find some simple solution to the differential equations, all right? Especially when they give you a condition, how do you find a particular solution? All right, so this is just an introduction. All you need to understand is what is a differential equation, what is the order of differential equation, and how do we check a solution. All right, thanks for watching.